So if binding energy is less than 0 negative, it means that when the nucleons are coming close together to form the nucleus, then their total mass will be less than the mass of the nucleus which is formed. Means when they are forming, some amount of energy is absorbed during that formation, so that energy will be reconverted into mass, so that after formation the mass of the formed nucleus will be greater than the total mass of its constituent nucleus. In that case, you can see that during formation, not mass is not disappeared but added, reappeared. Okay, so energy is not released but absorbed during that formation process. So binding energy will be negative. Energy is not evolved but instead it is absorbed. Okay, so binding energy in that case will be negative, and the mass of the nucleus is greater than mass of its constituent nucleus. So in that case the nucleus will be unstable. Okay, so because the energy, total energy, mass equivalence energy, if you think, it will be greater, so to become stable it will disintegrate itself through radioactive decay. Maybe some alpha particle will come out, or beta particle or positron, etc., to become stable. Okay, and the binding energy, value of binding energy is a measure of the stability of the nucleus. So if binding energy is greater, we can assume that the nucleus is more stable. That is, during formation greater amount of energy is released, so the nucleus will be a very low energy state, so the nucleus will be more stable. Now more is the binding energy, greater is the stability, and we need greater energy. We need to supply greater energy from outside to break down the nucleus. So binding energy of a helium nuclide He24 is around 27 mega electron volt. It means that we need to supply 27 mega electron volt energy to the helium nucleus to completely separate it into 2 protons and 2 neutrons. You see, in this helium nuclide there are 2 protons and 2 neutrons, 4 minus 2, 2 neutrons, and its binding energy is 27 mega electron volt. So to break down the nucleus into its constituent particles separately, we have to supply 27 mega electron volt energy. Okay, so it is just like through diagram you are showing this. So we have the stable helium nucleus, you are supplying 27 mega electron volt energy to the nucleus. As a result, what happens? The nucleus will be, helium nucleus will be broken up into its constituent protons and neutrons. Then just like average mass defect or packing fraction, we have average binding energy, which is average binding energy is defined as the binding energy per nucleon. So if binding energy of a nucleus is AB and mass number is A, then the binding energy per nucleon is AB by A. Now we will discuss one numerical problem. So we have to calculate binding energy of helium-4, okay, from the following data. Okay, so here you can see this proton number is not given, but we know the proton number of helium is 2. Okay, so mass of helium-4 is, it is given this much U. U is atomic mass unit, and mass of 1H. So what is 1H? 1H is basically 1H1, which is a protium, and I have already said that 1H1 also sometimes is used to represent a proton, because this protium atom, which is one of the isotope of hydrogen, there is only one proton in the nucleus, and there is one electron whose mass is negligible compared to mass of a proton. So sometimes this protium atom is used to represent a proton. Okay, and mass of protium atom is almost equal to mass of a proton if we neglect the mass of electron, which is this much atomic mass unit. Okay, and mass of neutron is given this much. Okay, and we have to calculate the binding energy. So we know the formula for binding energy is this EB equals to delta M into C square, where delta M is the mass defect. So at first we have to calculate the mass defect. Okay. So this helium 4, so it will be helium 4 nucleus contains 2 protons and 2 neutrons, that we know. Okay. So what is the total mass of the nucleus? Total mass of the nucleus is 2 into Mn plus a mass of neutrons 2 Mn plus mass of 2 protons 2 Mp. So then we are putting value of Mn and Mp. So this much atomic mass unit. This is the mass of nucleus. But what is the actual mass of helium nucleus? It is this much. According to the question, this much. So we may neglect the mass of 2 electrons because it is very small. So what will be the mass defect? Mass defect will be total mass of nucleus minus actual mass of the helium nucleus. So mass defect is total mass of nucleus, this minus actual mass of the helium nucleus, which is this. So the result is this. So this is the mass defect. So what will be the binding energy? Binding energy is mass defect into C square. So this much into C square, generally it will be delta M is this much U into C square. Now we have we have learned the energy equivalence of atomic mass unit. So instead of 1 U or 1 AMU, we are directly using 931 mega electron volt. Okay, so delta M is this, and then instead of U we are using UC square that we have used. We are using 931 mega electron volt, which is 28.29 mega electron volt. So if you have this kind of numericals, what you have to do? Suppose you have to calculate the binding energy in mega electron volt unit. So you have this much U. You take the number. Okay, binding energy will be take the number and multiply it by 931 mega electron volt, and the result will be the binding energy in mega electron volt.